Hi, I'm Paula Rizzonico.
And I'm Jonathan Swan, and this is our CS 2316 final project, Macroeconomic Regimes in the S&P 500, where we looked at how unemployment, inflation, and interest rates relate to stock market behavior from 2016 to 2026.
We both came in interested in finance, and we kept asking ourselves the same question. What actually drives the market, beyond what you hear on the news? We wanted to test that with real data instead of headlines.
Going in, we expected two things: that rising inflation and interest rates would correlate negatively with returns, and that distinct economic periods, like a recession versus normal growth, would be separable just from the macro numbers. So our objective was to build an ETL pipeline across three sources, clean and merge them into one data set, and use both statistics and machine learning to characterize that relationship.
We pulled from three sources, each a different method. First, IRS 2021 income data, a direct CSV download from the IRS Statistics of Income portal, which had about 27,000 rows.
And second, the Fed API from the St. Louis Fed, where we pulled the S&P 500, CPI, and the federal funds rate as JSON. And third, the Wikipedia list of S&P 500 companies scraped with beautiful soup. Those covered the download, API, and HTML scrape requirements.
Cleaning was a big part of this process. Fred returns missing values as a period instead of NaN, so we replace those. The IRS data records suppressed values as zero, which we converted to NaN so they wouldn't drag down our averages, and it has subtotal rows we had to drop before aggregating, or we would double count every state.
This, the three sources also used different date formats, so we standardized them. And the S&P 500 comes in daily, while everything else is monthly. So we resampled it to month end. That gave us one clean monthly table of 118 months. From there, we built five insights. I handled one and three, a linear regression testing whether macro factors predict returns, and a correlation and lag analysis.
I handled the clustering side. Insight 2 is k-means, Insight 5 profiles the clusters, and Insight 4 looks at income by state. Two of the five use scikit-learn, Jonathan's regression, and my k-means, and k-means is one of the models taught in lecture. So this is our headline result. I gave k-means only three inputs: unemployment, year-over-year inflation, and the Fed funds rate, and no labels. It had no idea what a recession is, and it still split the 118 months into three clusters that map onto real history: a stable growth regime, the COVID shock in 2020 and 2021 with unemployment near 15%, and the 2021 to 2023 inflation and rate hike period are most volatile. An unsupervised model finding the actual 2020 recession is strong evidence that it found something real. We didn't pick the three clusters arbitrarily. This elbow plot shows the inertia bending clearly at k equals 3. That's what justified our choice of choosing k equals 3. Here's the actual code. I built the shared monthly data frame, scaled the three features with standard scaler, which matters because k-means is distance-based, then run the elbow loop, and then finally fit the final model at k equals 3 and label each month.
Now, my side, the regression. I used unemployment, inflation, and the Fed funds rate to predict monthly S&P returns. The R squared comes out around 1.106, modest, which is a real finding. No simple set of macro factors cleanly predicts the market month to month. Unemployment carries the largest coefficient. And here's the code. I called the same shared data frame Panda Paula built, set my features and target, do an 80 to 20 train test split, fit a linear regression, and scored it with R squared on the held out test set. My third insight looks at correlation instead of prediction. Unemployment has the strongest correlation with returns, around 0.26. Inflation is weakly negative, and the Fed funds rate is near zero. I also tested 1 month lags, and they weren't strong, which suggests the market reacts to macro conditions in real time and not with a delay. The code uses SciPy's Pearson R, Pearson R for each indicator against returns, then shifts each indicator by a month and re-correlates to test for that lag. Different math from the regression answering a different question.
My last insight steps away from the time series to look at income geographically. Ranking states by average wages per return, there's about a 2 times spread, from around $49,000 in Mississippi to nearly $99,000 in DC, with coastal finance and tech states at the top. The clustering tells us when the economy was stressed, and the IRS data tells us where the income sits.
And this box plot shows my regression's residuals, actual minus predicted. The spread is wide, with the biggest miss around 9 points, which visually reinforces that modest R squared. Even the best linear fit leaves a lot unexplained.
So, pulling it all together, macro indicators have a measurable but modest link to short term returns, and unsupervised clustering independently recovered three real economic regimes with no labels, which was the most striking result we obtained.
And unemployment turned out to be the strongest axis separating regimes and the only significant correlate. And income is highly geographically concentrated. Beyond class, we learned time series resampling, feature, scaling first clustering, the elbow method, and lagged correlation. And turning clusters back into a story about recessions and inflation was our biggest challenge.
So, when it comes to our sources, our data came from the IRS, the Fred API, and Wikipedia.
And everything was done in course-top Python. Pandas, Sky,
Scikit-learn, SciPy, and Matplotlib. Thank you.